The environmental effects on enzymes. So enzymes are proteins, as I said, which means there are different things that can affect how they work, how well they work. The first one is that enzymes work best in their natural environment. So where they're going to have their best effects is wherever they're naturally found, because different parts of the body have different types of chemicals in them. The enzymes are going to be best suited to that part of the body. For example, an enzyme that's normally found in your stomach is not going to work as well in your heart, okay? Because there are different chemical environments in your stomach versus your heart. And so enzymes always work best in their natural environment. It says right here, changing that environment. So if I took a stomach enzyme and I stuck it in your heart, would affect the enzyme and therefore slow that reaction. So they are not going to work as well if they're taken out of their normal environment. Next, two types of ways that the environment can affect the enzyme. First one is called denaturation. Very important word to remember. Denaturation just means that the protein is going to unfold. Right? Why is that a problem if the protein starts to unfold? In other words, it starts to change shape. Then the active site changes shape. And as you know, the active site is like that puzzle piece that has to bind to the substrate. So if the puzzle piece is the wrong shape, it's not going to be able to fit with its match anymore, with its substrate. Okay, so that's a bad thing. The enzyme can't do what it needs to do if it denatures. The things that can make this happen are either extreme heat, so getting the enzyme really, really, really hot. So like, for example, in your body during a fever. That's one example of why you don't want to run a really high temperature, because some of your enzymes, which help the chemical reactions happen in your cells, will fall apart, basically, if you have too high a temperature, and they won't be able to do what they do anymore. And then there are other chemical changes that can make enzymes start to denature or fall apart. Changes in pH, for example, making things more acidic or more basic, are chemical changes for the enzyme that can make it fall apart. The other thing that can affect how an enzyme works is temperature. Temperature can, as I said up above, under extreme heat, denature the enzyme, but if you just make slight changes to the temperature, what it does is change the speed of the movement of molecules. Remember, we've been talking about the fact that these molecules move on their own, right? Random movement of the enzyme and the substrates within the cells are bouncing around. And if the speed of that movement changes, that makes them either more likely to run into each other. So if they're moving faster, they're more likely to run into each other, which makes the enzyme work faster. Or if they move slower, that makes them less likely to run into each other, which makes the enzyme move more slowly. Well, if we think about that in terms of temperature, we can increase temperature, which makes the enzymes move more quickly, or we can decrease temperature, which makes the enzymes move more slowly. Okay, so temperature can change how fast the molecules are moving, and therefore how quickly the reaction is happening. But don't forget, too much heat, and the enzyme completely falls apart. All right, now what does this have to do with your potato investigation? When you were looking at the potatoes, you were actually testing an enzyme that is in most cells. So let's start at the beginning of this to learn about what this enzyme is and what it does. So the first point I want to make for you is that most living cells make a waste product called hydrogen peroxide. And this is what you guys used in your little brown bottles in the investigation, was the hydrogen peroxide. So basically we were adding this waste product that cells don't like to the potato cells. Okay, so we were adding extra waste to the potato cells, and they didn't want that. In order to take care of this hydrogen peroxide that's normally in potato cells, right, we just added some extra. But cells make it on their own, so they are prepared for having that waste product around. They use the enzyme called catalase. Okay, so catalase is kind of the cell's way to combat this waste product, this hydrogen peroxide. What catalase actually does is, again, it speeds up a reaction of the hydrogen peroxide turning into water and oxygen gas. So in other words, if given enough time, that H2O2, that hydrogen peroxide, would break apart on its own into water and oxygen gas. But it would take a long time, not fast enough for the cell. Okay, it's a poison for the cell. The cell needs to get rid of it quickly. So instead, the cell uses this catalase. Uses this catalase to speed up that reaction, to get rid of that waste product more quickly. Well, water is a liquid, obviously, as a byproduct, which we know water can get in and out of the cell through osmosis. Oxygen gas is a gas, obviously, which can get in and out of the cell through diffusion. When you saw this result in your potato observations, you saw bubbling. What did the bubbling come from? Oxygen gas being given off. So the more bubbling you saw in the potato observations, the more effective the catalase enzyme was in breaking up that hydrogen peroxide that you were adding. And then you found the different variables that you added affected how well catalase worked. Adding certain variables made it bubble more, so catalase worked better. And then adding other variables made it bubble less, which meant that catalase was working not as well. And so the question in your analysis for your potato observations is why? What was it that was happening to the catalase that didn't work as well or showed less bubbling? What was it that was working well with the catalase that made lots of bubbling? So thinking back to what we talked about in this vodcast, you're going to have to answer some analysis questions about how catalase was working as an enzyme, what was its substrate, what did it bind to, and what were the products, what did it turn that substrate into? And then which variables made catalase work better and why? And which variables made catalase work worse and why? So the next step is going to be to work on those analysis questions, but don't forget to use this as a reference in answering those questions.